Joe for Tuesday, January 17th, 2023. Today we're looking at LeetCode problem 926, flip string to monotone increasing. This is a medium problem. And the problem statement says a binary string is monotone increasing if it consists of some number of zeros, possibly none, followed by some number of ones, also possibly none. You were given a binary string s. You can flip s at index I to change it from a 0 to a 1, or from a 1 to a 0. Return the minimum number of flips to make s monotone increasing. Okay, so I'll admit my initial solution to this problem involved traversing this from the string from left to right and from right to left, counting the number of ones at any given index, ones to the left of any given index, and all the zeros to the right of any given index. Then at any index, you can add the number of ones to the left to the number of zeros to the right, and that gives you the number of flips you'd have to make. And you just go through one more time, add up all these values, and find the minimum sum. Now, unfortunately, even though that's an O of n algorithm, it does not run in the time given. So we need a better option. So let's look at this a little bit more closely. You have some string. If the string starts with zeros, you don't need to do any flips. So any leading zeros are totally fine, no flips needed. As soon as you hit a 1, you may or may not need to flip. If the rest of the string is ones, you're again totally fine, no flips needed. Now if you get a 1 and then a 0, well now you need to do a flip. You either need to flip this 0 to a 1, or you need to flip this 1 to a 0. You don't really know which one yet. If you end up with more zeros, then you'll be better off flipping the 1. If you end up with a bunch of ones, you're better off flipping the 0. So one thing you can do is keep track of, from any point forward, keep track of the ones that came before, the natural ones that came before. Not any flipped bits, but the ones that came before in the input string. And then if you have a bunch of ones that came before your zeros, you can sort of weigh which option's better, flip the ones or flip the zeros. So let's break this down into our algorithm here. We're going to need some result, and we'll start it at equal to 0. Well, let's set 25 minutes on a Pomodoro timer. So we have some result, starts at 0, and we will return our result. Okay, then for every character in our string, there are two options. The character can be a 0 or a 1. So if the character is a 0, well, what do? Well, for now, I'm just going to pass. Else, it's a 1, and again, I'll pass. Okay, so if it's a 0, if we haven't seen any ones yet, we don't need to do anything. But if we have seen a 1, at this point, we'll need to flip either this 0 or that 1. Well, we're not keeping track yet of any ones, so let's keep track of how many ones we've seen. So start that at 0. And then anytime we do see a 1, we'll have to increment our ones. Okay, so now if we hit a 0, if we haven't seen any ones, we're fine. But if our ones count is greater than 0, maybe I'll call this ones count. That's probably better. Okay, so if our ones count is greater than 0, so we've seen some 1 before we got to this 0. Well, now at this point, we either need to flip that 1 that we saw, or we need to flip our 0. But either way, we're going to have to flip something. So we increment our result by 1. So in this case, this is where we get to sort of the trickiness. We have a bunch of zeros, then we hit some 1, then we hit another 0. Now at this point, as I said, we can either flip the 0 to a 1, or we can flip that 1 to a 0. Either way, we do one flip. Now if we keep moving on and we see more zeros, we don't need to flip any more values, because if we basically end up with a bunch of zeros after this 1, 1, we only want to flip the 1, 1. which means we only want to do the one flip with our result. So any zeros after this point, we don't need to do any more flips. So that means we're going to need to decrease our ones here, our ones count, by 1, because in that case, we'll just have flipped that 1. Now what happens if we see more 1s and then some zeros? Well, we'll either need to flip these 3 1s or we'll need to flip these 3 zeros. If we go through our algorithm here, we get to that first 0, we will flip either 1 1 or flip this 0. So that's 1 flip. We decrease this down to 2 1s, so it's kind of like saying we did something like this. Even though that would be technically 2 flips, it's more like, I guess it's more like we did something like that. Then when we get to our next 0, if we had any other ones that came before this, we want to keep track of potential flips. So we will, quote, flip this 1, and if we get to the final 0, we'll go and, quote, flip this other 1. Basically, those flips are decreasing this 1's count. It's tricky to explain. I think it's easier if you maybe write this out on paper and try to go through it on your own. But essentially what you're doing is you're keeping track of how many ones you've seen in the native string that was passed in before this point. If you get a 0 that came after some 1s, then you're going to have to do at least 1 flip. You either flip the 0 or you flip the 1. How many of those flips you'll have to do kind of depends on how many 1s you ended up seeing before this point and how many zeros you end up seeing after you found some 1s. So that's kind of what these two counters keep track of. The number of 1s that you've seen before and the number of flips you'll have to make. Okay, let's just run this and see how we do. And that passes. And we'll run the full suite, and it passes. So this is a simple algorithm. It beats 97% of the other solutions in terms of runtime. It beats 72% in terms of memory. All right, hope you enjoyed this. Hope you had some fun. Hope you learned something. Hope you can write better code.